Satellite communication, SATCOM. Imagine a soldier in the middle of the desert talking to command thousands of kilometers away. That's SATCOM at work. It uses military satellites orbiting Earth to send voice, data, and video across continents. From the US WGS, Wideband Global SATCOM, to the UK's Skynet, these networks make global operations possible. SATCOM is powerful because it links ground, air, and naval forces seamlessly no matter where they are. But it's not perfect. Heavy weather, signal jamming, or even enemy anti-satellite attacks can interrupt the link. Mobile Ad Hoc Network, MANET. Now picture a group of soldiers moving through a jungle with no cell towers in sight. MANET allows their radios and devices to automatically connect to each other, forming a self-healing network. Each soldier's radio acts as both a sender and a router, passing messages along like a digital relay race. The beauty of MANET is flexibility. If one node goes down, data finds another route. However, as more users join or move around, it becomes harder to manage bandwidth and signal clarity. High-frequency HF radio network. This is old-school tech that refuses to die. HF radio bounces signals off the ionosphere, letting troops talk over thousands of miles without satellites. It's used for long-distance naval or air operations, where infrastructure might fail. HF networks are resilient and cost-effective, but they can be noisy and require careful tuning. Still, when satellites are jammed or down, HF becomes the unsung hero of global military communication. Line of sight. LOS radio systems. Fast, direct, and reliable. That's the strength of LOS radios. They're commonly used between ground vehicles, aircraft, or ships within visual range. These systems transmit in UHF or VHF frequencies, allowing real-time voice and data exchange. The downside? Terrain or buildings can block the path. That's why armies often place repeaters on tall masts or drones to extend the range beyond hills and cities. Tactical Data Link, TDL. Tactical data links, like Link 16 or Link 22, are the nervous system of modern warfare. They connect aircraft, ships, and ground units into one synchronized picture. A fighter jet can instantly share its radar feed with a destroyer hundreds of miles away. That's how Allied forces coordinate precision strikes and avoid friendly fire. TDLs are secure and lightning fast, but they depend on encryption keys and careful frequency management to stay hidden from the enemy. Fiber optic battlefield networks. Some military bases and forward operations rely on fiber optic cables buried underground or rolled out temporarily. They're used for high-speed, secure command data, like live drone feeds, intelligence files, or encrypted communications. Fiber optics deliver massive bandwidth and resistance to electromagnetic interference. The drawback is mobility. Once the fiber is cut or destroyed, it's done. So it's great for semi-permanent bases, but less ideal for moving troops. Microwave communication links. Before satellites became common, militaries used microwave towers to pass data over long distances using line-of-sight beams. Even today, they're used for backhaul connections between bases. Microwave systems are fast and reliable when installed properly. Their main weakness is vulnerability. Towers can be physically targeted, and weather conditions can slightly affect transmission quality. Underwater communication systems. Submarines don't use regular radios. They rely on extremely low frequency, ELF, and very low frequency, VLF signals that can penetrate seawater. These systems allow silent, secure contact with deep-sea vessels without forcing them to surface. The speed is slow, but in stealth missions, slow and steady wins. The challenge? Massive antennas and specialized transmitters are required, often covering huge ground areas. Tropospheric scatter, communication. This clever technology uses the upper layer of the atmosphere to scatter radio signals beyond the horizon. Militaries use Tropo systems to connect distant bases without needing satellites or cables. It's like bouncing a message off invisible air currents. Tropo is valuable in remote or rugged areas. though signal quality can vary with weather and terrain. Still, it's an essential backup in case of satellite denial. Quantum and secure mesh networks. The future battlefield is going quantum. Militaries are now testing networks that use quantum key distribution to create unbreakable encryption. Alongside this, advanced mesh networks will connect drones, tanks, and troops in real time, adapting on the fly, even under heavy interference. These next-gen systems promise ultra-secure, jam-resistant links, but they're still experimental and expensive, waiting for the next big leap in hardware miniaturization and energy efficiency.